Now let us talk about irrational numbers. So we'll see what are irrational numbers. Then we'll see a few properties of irrational numbers. Then we'll see square roots. We'll try to understand the concept, and then how can we approximate square roots. And then we'll see irrational numbers and real numbers. Let us see definition of irrational numbers. So there are certain decimal numbers which do not end. That is, they are non-terminating. And also, they do not follow a repeating pattern. That is, they are non-recurring. So these decimals, which are non-repeating and non-recurring, they are known as irrational numbers. For example, 1.267 and so on. Now we can see that it is non-terminating because it does not end. And secondly, it is non-recurring because there is no repeating pattern. Next, say we have 3.14159 and so on. Now this is also non-terminating and non-recurring, and this is actually commonly referred to as pi. We'll see this later. Similarly, we have 1.141 and so on. So this is also irrational because it is non-terminating and non-recurring. This we will see later is the approximate value of square root of 2. Then we have 1.732 and so on. Another rational number which is non-terminating and non-recurring, and this is the approximate value of square root of 3. What are square roots? So the square of a number is obtained by multiplying the number by itself. Say we have a number x and I multiply it with x, another x. So I'm multiplying the number by itself. I end up getting what is called square of a number, x square. So x square is called square of the number x, and x in turn is called square root of x squared. So for example, say we have 3 multiplied by 3 is 9. So 9 is called the square of 3 and 3 is called the square root of 9. So this we commonly write it like this, square root. So square root of 9 is 3. Similarly, say I have 5 multiplied by 5 is 25. So I can say that square root of 25 is 5. Similarly, 0 multiplied by 0 is 0. So square root of 0 is nothing but 0. So we use the square root symbol to denote the symbol to denote square root. Square root of 16 will be 4. Seen that square root of 4 is 2, square root of 9 is 3. But what about for numbers like 2 and 3 which are not perfect squares? So because 4 is a perfect square, square root of 4 is 2. Similarly, 9 is a perfect square, so its square root is 3. But what about square root of 2? So the square root of 2 is not an integer. And now given that 1 squared is 1 and 2 squared is 4. So because 2 lies between 1 squared and 2 squared, so I can say that 1 is less than square root of 2 less than 2. So I can say that square root of 2 lies between 1 and 2 because the corresponding squares, so 1 square is less than root 2 squared, which is nothing but 2 itself, less than 2 squared, which is 4. So I can approximately say that the square root of 2 lies between 1 and 2. Similarly, 3 lies between 1 squared and 4. is 2 squared. So square root of 3 lies between 1 and 2. So now I know that square root of 2 and square root of 3 lie between 1 and 2. But then how do I find the value of square root of 2 and square root of 3? As it turns out, we won't be able to find the exact square root of numbers which are not perfect squares, but we can find the approximate value of square roots through trial and averaging methods. For example, let us find out square root of 2. So we know that it lies between 1 and 2. Now first step, let us take the average of 1 and 2. So the average would be 1 plus 2 upon 2, which is 1.5. Now let us check what is the square root of 1.5. This is 2.25. Okay, so this is greater than 2. Now what is the square of 1.4? It is 1.96. So now I know that 2 lies between 1.4 square, that is 1.96, and 1.5 squared. So now I can say that 1.4 less than square root of 2 less than 1.5. So I can say that square root of 2 lies between 1.4 and 1.5. Initially we were saying that it is between 1 and 2. Now we are able to come a bit closer and we are able to say that it is lying between 1.4 and 1.5. Now can we narrow it further? Say let us check with 1.41. So if we take the square of 1.41, so this is 1.9881, which is still lesser than 2. But what if we take 1.42 squared? This would be 2.0164, which is greater than 2. So 1.41 squared is less than 2, less than 1.42 squared, which means that 1.41 is lesser than square root of 2, lesser than 1.42. Now I'm able to get a bit more closer to the actual value, and now I can say that square root of 2 lies between 1.41 and 1.42. Can we go further? Let's go further. Let us check with 1.414. The square of this is 1.999396. What is 1.415 squared? This is 2.002225. So now 1.414 squared is lesser than 2, which is lesser than 1.415 squared. So this implies that 1.414 is less than square root of 2, which is less than 1.415. So now I am able to narrow the value of root 2 further, saying that it lies between 1.414 and 1.415. But for our general calculations, we take that square root of 2's approximate value is 1.414. Okay. So see, root 2 is not exactly equal to 1.414. It is greater than 1.414, and this is irrational. Root 2 is irrational because it neither terminates nor repeats. So I won't be able to find out the exact decimal value of square root of 2. But I can say that it is approximately equal to 1.414. Let us see what are real numbers and how do they correlate with irrational numbers. So numbers such as square root of 2, square root of 5, square root of 6, pi and so on, these are all irrational numbers. And what are real numbers? All rational numbers and all irrational numbers together form the set of real numbers. So from this video, I want you to remember three things. First, an irrational number cannot be expressed as a fraction. It cannot be expressed in the terms of p by q. Secondly, they're always non-terminating and non-recurring. Thirdly, square roots of non-perfect squares are always irrational.